Now we have in a chapter number 7, we have fractional indices. So we have a fractional indices. Fractional indices, it means that we have a indices which is like a upon b, like type this, no? So fractional indices. So let's see what the fractional indices are. So the question here is, suppose that a indices a raised to b is written like this. So now we have a question is, what is b, no? So for finding the b, we have to it's like we have to cube both sides, no? So cube both sides. So it's like this. For a reason that, suppose when we do the cube, this 3 will get cancelled, no? Let's suppose now. So 3b, a raised to 3b is equals to 1. Oh, sorry, it's just a. Now, when two numbers are equal, it means their indices are also equal. So from this you can imply, so 3b is also 1. 3 into b is equals to 1. In a also have a power 1, indices 1, so index 1. So now you can write b as like b is equals to 1 by 3. Now from here you got what is this? Okay, what is the b? B is a raised to 1 by 3, or this is can be written like this. It's a cube root. So here we have got the cube root. Now we can extend this law for n. So let's say extend it to give a general law. Is like this. When we have a raised to 1 by n with the type sign, so this can be written like this. So it's a cube root, so it's like the nth root. You can see. So if n is equals to 2, this become a square root. If n is equals to 3, it's become a cube root. So we have got the index sign for square or cube root or nth root. Let's do some example so we can understand it. So let's say we have for example, we have a question here, for example. So this was the fractional index, no? Fractional indices. A raised to 3 by 2. It can be written like this, no? A raised to 1 by 2 whole power 3, or you can write it like a root of a raised to 3, or also you can also write like this, because it's like this, no? 3 by 2 is 3 into 1 by 2. So a raised to 3 raised to 1 by 2, a raised to 3 by 2. So, or let me write it properly. So you can write it like this now. So square root will be changed like this. So this can also be written like this. The cube of a whole with the square root. So in a scientific calculator, it's like a wave sign like this. For this now, this is some kind of a number, and we get some this sign in a scientific calculator. When we have allowed to do the calculation with scientific calculator. It's a power key or something like this. You can find it out. So let's see, we have example. Example 7.5. So we have a question which says part A, write 5 nth root of a it's a fifth root like that. No? We write this using an index notation. So we have to convert this into an index using an index notation. So solution is like this. 5 this number can n raised to 1 by 5. So it's this. Now it becomes an index notation because n raised to 1 by 5. It's a fifth root. B. Now you have to evaluate this. Evaluate 16 raised to 1 by 4. So 16, when we have some kind of a 16 raised to 1 by 4, the index is this. So we can convert 16 in some prime factor. So 16 can be written like a 2 raised to 4, but I am doing like this because you can understand it. So when we divide 16 with 2, you will get 8. 8 divided by 2, you will get 4. 4 divided by 2, you will get 2. 2 divided by 2, you will get 1. So 16 can be written like this, 2 raised to 4. When you multiply, when you get the product of 2 4 times, you will get 16. So I can write 16 like this now, 2 raised to 4. So whole index is 1 by 4. So from now the index, you can say 4 into 1 by 4. So 4 will be cancelled. You will get 2 raised to 1 or just a 2. This is. You can also check from your calculator one. So you can say that it's a right answer. So So we have a part C, 25 raised to minus 1 by 2. So now here you can see 25 also written like 5 into 5. 5 into 5 raised to minus 1 by 2. 5 into 5, it will become a 5 squared. And 5 squared raised to whole minus 1 by 2. So 2 will be cancelled. So you will get 5 raised to negative 1. So it will become 1 divided by 5. So let's do some more exercise questions. Or some example. I say example. I should say example. So we have part D. Part D, 125 raised to 2 by 3. Now here you can write 125 as a 25 raised to 3. 25 raised to 3. You will get how much? I think it's too long, too high. Or 5 raised to 5 raised to 3. Let me confirm. So 5 into 5 you will get 25, and 25 into 5 you will get 5 into 5 you will get 5 here, 2 will go up. 5 into 2, it's 10, 10 plus 2, you will get 12. So we can write 125 as a 5 raised to 3 and whole 2 by 3. How I got here the 5 from 125? No? So you should write 125 here and think about how you can factorize it. No? So when you are to factorize some number, you have to think about which prime number can divide it. No? So 1 is not a prime, so skip. So 2 is a prime, but it cannot divide a 125 completely. So I mean there is no some kind of a decimal number. So you can use 3 here if you like it. So 3 is also prime, but 3 does not divide it completely. No? You will always get some decimal. So 4 is not a prime, so skip it. So go toward the prime numbers now, because any number can be converted it like a factorization in a factor of a prime number. So that's why I'm getting 5 raised to 3. So you can do like this. So 2 and you will get 25. So 25 divided by 5, 5 and 5. So now indices you can simply 3 into 2 by 3 multiply them. You will cancel 3 with 3 and you will get 5 raised to 2 and you will get 25. Simple as that. So note. It's important note that either the cube root or the square root can be calculated first. The final answer result will be the same. So here I was using the factorization type, no? But you can think about it like a 5 raised to 3 and into 1 by 3. It's like I'm using a cube root. So 3 will cancel and 5 raised to 2 you will get 25. So but similarly you can also use this too now, but it will get some lengthy, that's why I'm not using this now. So what the note says, either the cube root or the square root can be calculated first. The final answer will be the final result, or final answer, final result will be the same. So it is often easier to work out the root first. So as we have used 1 by 3 now, this was the root now. So always used root first now. Work out the root first. When you say work out the root first. So we have exercise 7.5.